Okay, hello everyone. In a new video, this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2008, first session, first exercise. So the title of this exercise is Image Given by Converging Lens. The object of this exercise is to determine the characteristics of the image A prime B prime of an object AB given by a converging lens L. The diagram below shows a converging lens L. They mentioned the diagram. So now I can use the figure. Its optical axis x prime o x, its two foci f and f prime, and the object AB. Okay, so here in the diagram, we have the optical axis x prime x, and the lens L perpendicular to the optical axis. The direction of propagation of light is from left to right. We have the object AB. Moreover, they didn't mention whether f is the object focus and f prime is the image focus, but because the direction of propagation of light is from left to right, then the lens that I'm using is a converging lens, then f is the object focus, which is on the left, and f prime is the image focus, which is on the right. So now number 1, part 1, they are telling me construction of the image A prime B prime. Okay, in number 1, in part 1, reproduce on the graph paper the above diagram with a given scale. So always whenever we need to reproduce, we always start by drawing the optical axis at the center, at the middle. This is the optical axis. Okay, then we place the lens L perpendicular to the optical axis at the center. Let me label some stuff. Here the direction of propagation is from left to right, then the optical axis has the same direction. This is the symbol of a converging lens. And as we know, the intersection between the optical axis and the lens L is the optical center O. Okay, this way. Okay, now the point F is located 1, 2, 3, 3 divisions in front of L, so 1, 2, 3, and F prime is the symmetric of F with respect to O. Now the point C is located 1, 2, 3, 4, 5 divisions in front of the lens. So 1, 2, 3, 4, 5. This is the point C. The point B is located 1 division above A, and a hat is found on B. Now the point A is located 1 division below the lens. This is the point A. Now let's trace the object. Okay, and the figure is given to a real scale. In other words, 1 centimeter along the x-axis and 1 centimeter along the y-axis. Then this is the reproduction. Hope we didn't forget anything. Now in number 2, they are telling me construct by tracing two particular luminous rays the image A prime of A. Okay, so by construct means that we need to trace and justify at the same time. We need to trace and justify the image A prime of A. So as we know, in order to trace the image, we need to consider two particular luminous rays. Then the first one that we will consider is parallel to the optical axis, and we know that this ray will emerge passing through the image focus. Okay, now the other ray that we will consider is passing through the optical center. We know that it emerges without deviation, and we don't forget arrows on all light rays, so on incident rays as well as emergent rays. Now let's justify the path of these two rays. Okay, so the justification of the ray parallel to the optical axis, an incident ray issued from which point from A, because we are determining the image A prime of A, issued from A parallel to the optical axis, emerges passing through the image focus, now the justification of the second ray passing through the optical center, an incident ray issued from A passing through the optical center emerges without deviation. So what we have done so far is the tracing and the justification of the rays. Now we need to trace and justify the image. Okay, let's trace it first. We always know that the intersection of the emergent rays is the image of the object. So notice that these two rays, emergent rays, are coming from these two incident rays that are coming from A. Therefore, their intersection point, which is here, will be the image A prime of A. Moreover, there is no hat found on A, so we no need to place anything on A prime. Now let's do the justification. Then the image A prime of A is the intersection of the emergent rays. Now in part 3 they are telling me specify with the justification the image C prime of C. Okay, so here in other words, specify with the justification means that I need to trace and justify. Notice that here I need to trace and justify the image C prime of C. Notice that here C represent, this is the point C, it represents the foot perpendicular of A on the optical axis. Therefore also here C prime will represent the foot perpendicular of A prime on the optical axis. This is A prime and this will be C prime. Now let's trace the image A prime C prime of AC. Okay, and let's do the justification. Then the image, okay, so let me say, okay. C prime is the foot perpendicular of A prime on the optical axis. Okay, now in part 4 they are telling me determine by tracing only one ray the image B prime of B. Okay, also determine and tracing means that I need to trace and justify at the same time. So first let's do the tracing. They are telling me by only tracing one ray. Then let's consider a ray issued from B. We will take the easiest, which is passing through the optical center like this. Then this is a ray issued from B passing through the optical center. We don't forget arrows on light rays. Now they are telling me using this ray we need to determine the image B prime of C. Now first of all, because all rays issued from B emerges passing through B prime, therefore the image B prime of B will belong to this emergent ray. Okay, but moreover here notice that the point B belongs to the line AC, therefore B prime will also belong to the line A prime C prime. Therefore B prime will be the intersection of this emergent ray with the line A prime, C prime. So this is B prime. Okay, I repeat, because B prime belongs to this emergent ray and B belongs to the line AC, therefore B prime will also belong to the line A prime C prime. Then we have that B prime belong to the emergent ray and to the line A prime C prime. Then B prime, this point will represent the intersection of this emergent ray with the line A prime C prime. Now a hat is found on B directed away from the optical axis, therefore we must place a hat on B prime directed away from the optical axis like this. Now let's do the justification. Now we are in part 4. Here we need to justify the path of this ray and as well as the construction or the tracing of the image. First, let's do the justification of this emergent ray, which emerges without deviation. Okay, an incident ray issued from B, passing through the optical center, emerges without deviation then the image B prime of B is the intersection of the emergent ray with the line A prime C prime. Okay, so this is it for part 4. Now we are in part 2, number 1. They are telling me characteristics of A prime B prime. Number 1, give with the justification the nature of A prime B prime. Notice that AB is located in front of the lens, whereas the image A prime B prime is located behind the lens, which means that the object and the image are on opposite sides with respect to the lens, which means that the image is real. Okay, we know that always when the image and the object are on opposite side, then the image is real. And let's say the following: since the object AB and the image A prime B prime are on opposite sides, then the image A prime B prime is real. Okay, now in number 2 they are asking me, is A prime B prime erect or inverted with respect to AB? So in other words, they are asking me about the direction of the image. Notice that the object here is pointing upward, whereas the image is pointing downward, which means that the image A prime B prime is an opposite direction with respect to AB, which means it is inverted. Okay, then we will say the image A prime B prime is inverted with respect to the object AB. Now in number 3 they are telling me determine the length of the image A prime B prime. So whenever they ask me about the length of the image or the height, in other words, this means the size. Now let's calculate the size of the image A prime B prime. Now A prime B prime consists of 0.5, 1, 1 and 0.5 divisions. So if we add this up, 0.5 and 0.5, this will give me 1 plus 1 plus 1. So A prime B prime consists of 3 divisions. And we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis, and this will give me 3 centimeter. Why centimeter? Because the scale is in centimeter, and always all quantities in physics must have a unit. Finally, it's a good habit to write our final answer in box to make the task easier for the corrector to notice our correct answer. Now we are in part A. They are asking me the image A prime B prime of AB may be collected on screen Y. So in part 1 of this question, which is question 2, we have proved that the image A prime B prime is real, and we know that a real image can be collected on screen. So yes, it can be collected on screen because it is real, since only a real image can be collected on screen. So now in part B, they are telling me at what distance D from L should this screen be placed. Okay, because the image A prime B prime is being collected on the screen, in other words, this distance D represents the distance lens image. So we need to determine the distance between the lens and the image. Now this distance D consists of 1, 2, 3, 4, 5, 6, 7, 7.5. This is 0.5. So 7.5. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis, and this will give me 7.5 centimeters. Then D is equal to 7.5 centimeters. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching this video, and see you soon in another one.